You understand the general shape and how to predict what it's going to look like. So here is the graph of y is equal to log base 3 of x. All right. And if you remember that logarithmic graphs, go back here, if I have 3 to the x, we know that that is an exponential graph. It looks like that. The log graph is the inverse of it, right? So it looks like that, and they have a little reflection there. So they're inverses of each other, okay? All log graphs have a vertical asymptote. All exponential graphs have a horizontal asymptote, okay? So the vertical asymptote here is at 0. If I change the base to 10, all that's going to do is it's not going to change the vertical asymptote. It's going to change how fast it rises, and it actually rises a little slower. So I'm going to start it here. So it's sort of underneath at this point. Again, I'm not really too concerned about how far up and all that kind of stuff they go. What I'm going to care about is the vertical asymptote and the general shape of the graph, okay? Now, what if the base is a fraction, a proper fraction? So we've gone from base 3 to base 1 over 3. If I use change of base rule on this, you don't have to write this down. You can just watch. I can write this. So change of base rule is this rule right here. It says I can take whatever my argument is, and that becomes the argument in the numerator, and the base becomes the argument in the denominator, and I can choose any base I want, okay? So just for argument's sake, I'm going to choose base 3. Yeah, I want to do base 3. So I'm going to go log base 3 of x over log base 3 of 1/3. Okay, all I did was use this rule here. Now, can 1/3 be made into base 3? 3 to the minus 1, right? I should have 3 on it. 3 to the minus 1. These two match. So what does that become? -1. So now, and the bottom is just goes away essentially. So I'm left with negative log base 3 of x. Does everybody agree with that? Okay. How does this graph or this function compare to, well, this one right here? In think transformations, what is that negative in front of it? Taking this one, I put a negative right in front of it. What value is that? It's an A value, and it does a reflection, right? So that means that this log base 3 has now reflected over the x-axis. Your x-intercept stays the same. And now the graph is coming like that. So that is, whoops, negative log base 3 of x, which we just showed is the same as log base 1/3 x. Okay? So if you have a proper fraction as your base, it's still got a vertical asymptote, but it is now a decay graph, a logarithmic decay. Okay? So what do you think the graph of 1/10 is going to look like? It's essentially a reflection of log base 10 of x. Okay? So it goes through the same point. The orange is y is equal to log base 1/10 x. The key here is if the base is a proper fraction, the graph is decreasing. If the base is greater than 1, 3, 2, 10, 50 billion, doesn't matter, it is a growth, a logarithmic growth. Okay? Are we good with that? All right. So we're just going to do a couple of these. Do this one, and we'll do this one. All right. What's the domain of a log graph? Let's look at those two log graphs. Log base 3 of x and log base 1/3 of x. Looking at the... XER. Not XER. Where's the vertical asymptote?
X is greater than 0.
Yeah. Vertical asymptote is here, and all the graphs are this way. So x is greater than 0. All right, cannot be 0. Try putting 0 into the log graph, it blows up. All right, what's the range? Are there any limits on the y values? No, so it's all real numbers, right? So you can either say YER, or you can say from negative infinity to positive infinity. I don't really care how you say it. X-intercept. Where does it hit the x-axis? At 1. So 1, 0, 1, 0, because y is always 0 at the x-intercept. Y-intercept? Nope. Let's cross those out. Asymptote? It's not y is equal to 0, it's x is equal to 0, because it's a vertical, right? And I don't actually care about that bit there. Okay. All right, so we have a vertical asymptote at x is equal to 0. We have a growth if the base is bigger than 1. And we have a decay if the base is less than 1. All right? There we go, right here. Page, oh my gosh. Page 256, please. Okay. What does that 2 do to the graph? 2 log 3x. What does that 2 do? Just tell me in words.
You gotta move it up.
This one?
Yeah.
What value is that? A, B, H, or K?
B. No, it's not.
It's A, right? Remember, A, F, B,
Yeah, it's A.
X minus H. That's our equation. It's an A value. What does an A value do? Vertical, I don't know who said that. Vertical stretch. So that's A is equal to 2. So it's a vertical stretch by 2. Okay. Basically, that's just going to stretch the graph like that. So all your values get multiplied by 2. So that stays the same. This 1 gets multiplied by 2, goes to 2. This 2 goes to 4. So basically, the graph just looks like this. Y is equal to 2 log 3x. It's not that interesting. The domain hasn't changed. Vertical asymptote is still at x is equal to 0. We just kind of stretched it out. What about this one? Log base 3 of x minus 2. What value is that?
H.
That is your h value. Which way does the h value move it? Left or right? Which way does this one go?
Right.
It goes right. So our h value here is 2, which means we go right. Now, just like in a exponential graph, when you move that up and down, what moved with it? the horizontal asymptote on an exponential. In a log graph, if you move it left to right, the vertical goes with it. Okay, so this graph we'll do in pink. Horizontal asymptote is at 0. We move it 2 units to the right, so now it's at 2. So x is equal to 2. And we just took this graph, this black graph here, y is equal to log base 3 of x, and we just move it 2 to the right. So this point that's at the x-intercept at 1 is now at 3. It's still a growth. Everything else is the same. Y is equal to log base 3 of x minus 2. What's the domain of this graph? X is greater than 2 because we've moved the vertical asymptote over. So the domain is x is greater than 2. All right, last one. Y is equal to log base 3 of x minus 2. Is that an h or a k?
H. Oh no, that's a K.
It's a k value, right? Because it's this one is in brackets, so you know it's an h value. This one is not bracketed, so that is a k. K moves it up and down, so we went down 2. Down 2. Green. So you take this graph, you move it down 2. It's still the same type of graph. That's really that's not what it looks like. Because it moves all the points down 2. So it looks like this. That's really bad too, but whatever. Okay, so it's been moved down 2. And it shouldn't be as wavy as that one that I drew. Okay. Did it change the domain? The only thing that'll change the domain on a log graph is the h value. Okay. So domain, come on. Domain is still XER. Okay. So only h value will change domain on a log graph, and the h value equals the VA, the vertical asymptote. Yep. Yeah, not XER. Thank you. Sorry, peoples. X is greater than 0. I don't know why I said XER. Okay, so the domain is still x is greater than 0. All right. So what do I expect you to be able to do on a log graph? Where do you have space?
On the next page.
Do you have space on the next page?
Quite a bit of it.
Oh, perfect. Okay. Don't worry about that stuff. Right here. Here's your summary of log graphs. Log base b of x. If b is greater than 1, it's a growth. There you go. If b is between 1 and 0, because you cannot have a negative b, all right? Negative base. So this means it's a fraction. It is a decay. Looks like that. If you have an h value that is your vertical asymptote. And x is greater than, your domain will be x is greater than your h value. Is that okay? All right. So the only question we're going to do from this is question number 6. So if you go to number 6, all I want you to do is I would like you to sketch them. Okay. Quick sketch with the vertical asymptote and the domain. Okay.